And welcome to this, sorry about that. Welcome to this special Western Drought Media briefing on the Intermountain West, California, and Nevada. My name is Veva Deheza, and I am the Executive Director of NOAA's National Integrated Drought Information System, or NIDIS. NIDIS was established by Congress in 2006 by public law and was reauthorized twice with strong bipartisan support in 2014 and 2019. NIDIS is an interagency program that sits within the Climate Program Office, which is part of NOAA's Office of Oceanic and Atmospheric Research, otherwise known as NOAA Research. NIDIS's mission is to develop and provide a national drought early warning system, to coordinate and integrate as practicable federal research in support of a drought early warning system, and build upon existing forecasting and assessment programs and partnerships. I would like to thank everyone who worked to put this briefing together, including our federal partners across NOAA's National Weather Service, Office of Oceanic and Atmospheric Research, the U.S. Department of Agriculture, and our colleagues at the National Interagency Fire Center, as well as our academic partners and sector-specific representatives. Next slide, please. First, allow me to cover some housekeeping items. At this briefing, participants are muted and the briefing is being recorded. The recording will be available on the NIDIS YouTube channel and linked from the briefings event page on drought.gov. Please check the chat box periodically throughout the briefing for links to some resources mentioned in this briefing. We have 2 times on the agenda to take a few of your questions. For questions in today's webinar, we will use Slido. Next slide, please. If you are joining from the WebEx desktop app or web app, you can participate by using either the Apps or Slido button at the bottom right-hand corner of your WebEx window. Please include your name and affiliation in your question. We will get to as many questions as possible in the allotted time we have, and will provide contact information for follow-up if needed. Next slide, please. The 2026 Western Media Drought Briefing that's being held today, will deliver timely and relevant drought and fire conditions, outlooks, as well as perspectives from decision makers on the ground who are experiencing and responding to the significant impacts of this drought. The briefing will include a summary of past, current, and forecast drought conditions, including ENSO and monsoon outlooks. We will also learn about potential and ongoing impacts from drought across communities and sectors. We hope this briefing will be useful in helping you to translate complex drought-related data into clear communication that resonates with communities across the West with the impacts of this drought. Communities that are grappling with the impacts of this drought. Next slide, please. I am very pleased to introduce our distinguished opening speakers who will help us kick off this briefing. We will first hear from Dr. Tim Petty, NOAA's Assistant Secretary of Commerce for Oceans and Atmosphere, and Deputy NOAA Administrator. Dr. Petty's portfolio oversees the strategic vision, policy direction, and oversight of NOAA's oceans, mapping, and fishery programs, and he has spent his career at the intersection of water science and Western resource management. After Dr. Petty, we will hear from Ed Clark, who is the director of NOAA's National Water Center and deputy director of the Office of Water Prediction within the National Weather Service. Ed Clark oversees the advanced forecasting and national modeling driving our water intelligence for communities nationwide. And so now I'd like to introduce NOAA's Deputy Administrator, Dr. Tim Petty. Welcome, Dr. Petty.
Yes, thank you, Viva. I greatly appreciate everyone being able to join us today. Looking forward to even Ed Clark's comments and the work that we've done in the past and continue to work on this important area. For you and for the kind introductions regarding the drought conditions across the Western United States, thank you. on behalf of NOAA and NIDIS and all the colleagues working together on really building out a platform that is not only incredibly useful, but a part of every aspect of water, and especially Western water in and of itself. Today's droughts are affecting water resources in many ways and have been seen before in this modern age, and water management for change in water usage, the water levels, especially major reservoirs in the West, decreased hydropower capacity and capabilities, as well as changes in runoff from snowmelt, creating a large gap between peak runoff and peak demand. Farmers, ranchers, and utility companies, transportation companies, and water-dependent businesses need time-sensitive and locally relevant drought information to make decisions on when to plant, how to manage their livestock, and to when to conserve and seek alternative water supplies, whether they are shipping or doing navigation or just water use in their local communities. Each of these areas are dependent on information, and information that are timely. As we all know, this past winter, the West has experienced an unprecedented amount with snow drought. This has a direct impact on spring, summer, and fall capabilities for water. As the nation's provider of authoritative weather forecast, NOAA plays a vital role in protecting livelihoods during a drought event such as the one we are in, especially out in the West. This world-class Earth systems monitoring and capability in advanced cutting-edge capabilities applied through drought research are key tools in servicing the information that is available to all these area communities. Drought plays a huge impact even for myself, whether I was years ago on my family farm and my family still uses a lot of this information on crop and crop capabilities each and every day, month, and year. Today, our team will deliver to you innovative, high-impact science that NOAA is providing for breakdown for the capability of current hydrological conditions. And we will be wanting to walk through this late summer outlook and also fire outlook on how to look at and navigate in decision making into the summer and fall capabilities. I want to also mention that this marks the 20th anniversary of NIDIS's establishment by Congress. For the last 20 years, NIDIS has supported the West in preparing for drought and wildfires, as well as water supply that depict and have deficits in areas on drought conditions, and build on forecasting models that give these communities the ability to plan on what's next steps to be taking. Finally, I wanted to just take a moment to acknowledge the members of the media who are joining today. The truth is, NOAA science can only serve the public if it is actually reached by the public, through the public, and it's through the media in which so much of the media and the community is served. So we are grateful for you who are joining us today on this webcast. The media plays an important part in delivering this critical drought information to the people who need it most. With all that, I'd like to go ahead and turn back the mic to Veva. Thank you so much.
Thank you, Dr. Petty. I will now welcome Ed Clark to make a few remarks.
Great. Thank you, Veva. Thank you, Dr. Petty. The mission of the National Water Center is to provide and produce actionable water intelligence, from too much in terms of floods to too little in terms of droughts. Indeed, NIDIS is a critical partner in the delivery of that information. NIDIS, the coordinators at NIDIS were some of the first to tell the comprehensive story about this year's evolving snow drought, which preceded the water supply forecast issued by the river forecast centers, some of which across the West are some of the lowest on record in the last 25 years. NIDIS is a critical partner, not only in the development of actionable intelligence, but in the research that goes into the tools and capabilities that we operate here at the National Water Center. Working with NOAA Research, we are collaboratively funding activities to invest across capacity expansion for water in the West. Tools like new snow accumulation and ablation models, forecast-informed reservoir operations, and ensemble forecasting capabilities underpin the tools and capabilities of the National Water Center. And so all of these is to say that NIDIS is a critical partner, but our partnership and the communication, the stories that we tell about drought can only reach, as Dr. Petty said, the public and those who need this information most through our collaboration and partnership with media. So I want to thank you on behalf of those who are sitting here forecasting, working across the nation to provide water intelligence for your time today and your attention on this critical national security issue. Thank you. I'll turn it back to you, Veva.
Thank you. Thanks, Ed. Thank you both for joining us today and for providing a very important context for our briefing today. At this time, I will now turn it over to my colleague, Amanda Sheffield, to introduce the first panel.
Great. Thank you, Veva. As she mentioned, my name is Amanda Sheffield, and I am the California Nevada Drought Early Warning System Coordinator at NIDIS. The first panel in today's briefing will focus on drought conditions and forecasts and the seasonal fire outlook, and will be structured as follows. You'll see many of their names here on the screen, but we'll first hear from Dr. Daniel McAvoy from the Desert Research Institute, followed by Brad Pugh from the Climate Prediction Center at NOAA's National Weather Service. After them, we'll be joined by Dr. Mike Crimmins from the University of Arizona to share about the ENSO and Monsoon outlooks, as well as Kathleen Clow from the Desert Research Institute to provide the significant wildland fire potential outlooks. This will be followed by question and answer. I first would like to welcome Dr. Dan McAvoy. Dr. McAvoy is a researcher in the Division of Atmospheric Sciences at the Desert Research Institute, where his primary focus is on drought, snowpack, and mountain hydroclimate dynamics in the Western United States. The Western Regional Climate Center is one of 6 NOAA-funded centers across the U.S. and is housed at DRI, and Dan serves as the regional climatologist. His work for WRCC includes climate services, communication and outreach, and oversight and development of user-inspired web tools to access and visualize climate data. Take it away, Dan.
Okay, well, great. Thank you so much for that introduction, Amanda, and also to Veva. And thank you for giving me the opportunity to provide this briefing today. So there's a lot to cover with everyone today, so we'll jump right into it. Next slide. We briefly saw this slide from Veva in the opening remarks, but this is a map of the latest U.S. drought monitor, basically a snapshot of the most recent drought conditions in the Western U.S. That's updated once a week. This one was released last Thursday. There'll be another one coming out tomorrow. So it's pretty obvious here that drought is widespread across the Western United States. Currently, about 72% of the area in the West is covered by drought. That's the highest spatial extent of drought covering the West since 2022. And then on the right there, you have the states in the regions being covered today. And for the most part, all these states have a lot of drought in them. And then in some areas, there's extreme and exceptional drought present, particularly in the Intermountain West. California is one exception that has very little drought present right now. And I'll get a bit into why that is next. And I also wanted to highlight that this drought has been ongoing now in some places, particularly in the Intermountain West, for several years now. And so it's been widespread for several years, and it's been increasing in severity over the last year. Next. So I also want to start out with the water year temperature and precipitation maps. These are from the West-wide Drought Tracker from the Western Regional Climate Center. And so these cover October through June. On the left, we have temperature, and on the right, we have precipitation. So it has been persistently warm all water year in the Western U.S., and I can't emphasize enough how big of a role these temperatures played in the snow drought and the ongoing drought conditions. All those areas in that darkest red shading, most of the Southwest, have had their record warmest water year since 1895. And there's no blue to be found on that map at all, no colder than average places. Then on the right, we have the precipitation percentiles. And this is a bit more interesting as there is no widespread extreme dry signal across the Western U.S. There are some areas that have been very dry, including the Colorado Rockies, Utah, parts of Wyoming. But if you look at places like California, the Sierra Nevada, they've been near normal or even above normal precipitation for the water year in some instances. That's partially why their drought extent is less in California. Next. And so there was an extreme snow drought this year across all of the Western United States. And so this is despite the previous precipitation map showing variability in where there were wet and dry conditions across the Western U.S. And this was largely driven by warm temperatures, and those temperatures were a major factor everywhere across the Western United States in terms of snow drought. This map is showing the snow water equivalent from April 1st as a percent of the median. All those reds are less than 50% of median, and pretty much the entire region being covered today was less than 50%, and in some cases a lot less than that. There were several states that had their lowest April 1 snow water equivalent on record. And so what we had this year was extremely warm temperatures during the winter, showed on the top right, and the atmospheric freezing levels, the highest on record by a long shot, almost 4 standard deviations above normal. And so that translated to more rain and less snow in the winter, and also more snow melt during the middle of the winter, really driving the snow drought. Next slide. And then on top of that, there was an extreme event in March, and so we had the extremely warm winter, and then we had an unprecedented March heat wave. And this map on the left is showing the monthly mean temperature departures from average for the month of March. A lot of places in the region had temperatures 5 to 7 degrees Celsius above normal for the month. And this really triggered a very rapid and early snow melt. And what really this led to was the snowpack disappearing much earlier than normal, in a lot of cases over a month early, and in some cases a lot more than a month early the snowpack disappeared, which is also contributing to the developing drought this summer. Next slide. So how did this snow drought then translate into runoff and water supply? We heard a bit about the water supply concerns in the Western U.S. So this now is a map showing the basin average water year, so October through June total runoff for each of those basins shown. And so it was very low runoff for most of the Western United States. And that WY is water year, it's not Wyoming. So most places for the water year, one exception being California and the Sierra Nevada. And that's rather interesting when you look at how bad their snowpack was. There was still relatively decent runoff in the Sierra Nevada due to the average precipitation that they found. But through the Intermountain West, it was some of the lowest snowpack or lowest runoff on record for the water year. But where things got really worse was in this warm season, the water supply runoff season, April through June, now being shown on the right. The values are even lower, a lot of places less than 30% of average runoff in April through June. And this was due to that shifted timing of the runoff and the snow melt due to the warm winter and also the March heat wave that we saw. So overall, extremely low runoff for much of the region. Next slide. And then we can look at how this translated into reservoir conditions once that runoff from the rivers comes down the mountains and makes it into those reservoirs. And so this is a map from the Bureau of Reclamation showing major reservoirs in the Western U.S. as the circles, and the reds are below average conditions and the blues are above average. And the bottom right is highlighting those areas that are really critically low. You have Lake Mead, Lake Powell, and Elephant Butte that are all critically low. And this is not just due to the drought this year. This is a drought. This is a water supply crisis in the Colorado River Basin that has been ongoing for a couple of decades now. And so it's still critically low there. It's also quite bad in parts of Colorado, Wyoming, southern Idaho. But in California, the reservoir conditions are not quite as bad. And so the combination of the snow drought plus the warmth plus that really low runoff, really made things worse in a situation that was already in crisis in the Colorado River Basin, especially. Next slide. And so I did want to also show the California reservoirs just to highlight that they're actually in pretty good shape right now. The water supply in California is looking good. Every single one of these major reservoirs, except for one, is above average for this time of year. And so that's due to a combination of the near average or above average precipitation from this year, combined with the previous 3 years that were not drought years in the area that had either average or a really big year in 2023 that filled everything up. And so we have this buffer from the reservoirs in California, a much different situation than what's going on in the Intermountain West and Colorado River Basin right now. Next slide. And finally, I just wanted to mention what's been going on more recently, things that have been working to dry out the landscape and increase the summer drought conditions. So on the left, we have the evaporative demand drought index, which represents the thirst of the atmosphere, how much water the atmosphere wants to take off the land surface and dry things out for the last 30 days. And those reds are much above average. And there's some really extreme evaporative demand anomalies showing up right over the Four Corners area. And other areas, it's not nearly as bad. And so this happens to also be the area where there's very high fire activity right now and fire danger as well. And that is not a coincidence. And then on the right, we have the map of soil moisture conditions. And all those browns are areas where the soils are drier than they should be for this time of year. And so you see that standing out a lot, especially in Colorado and that Four Corners area and parts of Nevada and Wyoming as well. And so next slide. To summarize real quickly, we do have this widespread and severe drought present in the region. The snow drought was a big factor in making things a lot worse. And the warm temperatures were a huge factor in driving that snow drought. And so in the short term, we have warmth and extreme evaporative demand that's really driving this increased drying of the landscape and increased fire danger. So thank you very much again for the opportunity, and I'll leave it at that.
Great, thanks, Dan. Ryan, folks, will answer the questions after our first panel and go ahead and keep entering them into Slido. But next we'll hear from Brad Pugh. Brad is a meteorologist at NOAA's National Weather Service Climate Prediction Center, and he's been there for 26 years and a drought outlook forecaster for more than a decade. His forecasting responsibilities include the following outlooks, including the 6 to 10 day and 8 to 14 day temperature precipitation, week 3-4 temperature precipitation, monthly to seasonal temperature and precipitation, as well as the week 2-3 global tropics hazards and the week 2 U.S. hazards. In recent years, he's led and helped implement a rapid onset drought risk tool for week 2 in the U.S. Go ahead, Brad.
All right, thank you, Amanda. And yeah, Dan provided a really good overview of where we are right now with the drought conditions over the West. Had the snow drought this past spring, and then more recently, the increase in wildfires over the Four Corners region. So I'll show the drought outlook on the final slide. But before we do that, I do want to go through a couple of slides on what to expect during the next couple of weeks. As we're going through some weather changes over the West during mid to late July. And what I have here is the week 2 temperature outlook, valid July 15th through the 21st. So you can see large above normal temperature probabilities throughout the West, but especially focused over the Great Basin, Intermountain West region. And then on the right-hand side is our week 2 hazards outlook. And we do have a moderate risk of extreme heat posted for the Central Valley of California and the lower elevations of the Great Basin. And where you see those that extreme heat, the moderate risk, let's say a 40 to 60% chance that temperatures would reach the threshold for heat advisory or excessive heat warnings from the local National Weather Service forecast office. Right now, we do have extreme heat warnings ongoing in the desert Southwest. So as we go through the weekend into next week, we are expecting that heat to become more focused northward over the Great Basin. And this is, obviously it's bad for intensifying drought, but typically these kind of heat spells do precede the onset of the monsoon. And we're pretty confident that's going to occur during the next 2 weeks. So next slide, please. All right, so you can see the precipitation outlook on the right-hand side there, where we're favoring above normal precipitation from July 15th through the 21st. Have greater than a 50% chance of above normal precipitation there in Arizona, and then a 40 to 50% chance as far as north as Nevada and southwestern Utah. So yeah, a couple things are driving this enhanced monsoon. We have the heat over the next week, and then that ridge axis, which I have defined by that solid black line, that's forecast to become centered right over the Four Corners region, and that's really what you want to see for an enhanced monsoon. So this is the GFS model forecast. European model is very similar. This is from yesterday, and today's model solutions are right on track for this enhanced monsoon coming up during the latter half of July. Next slide. Okay, so as we take the next 3 months together, so this is the July, August, September temperature and precipitation outlooks. So we have above normal temperatures favored throughout the West, and then above normal precipitation favored over the desert Southwest, northward into the Intermountain West. We do have the highest probabilities between 40 and 50% of above centered on Utah. And go ahead to the next slide. Yeah, so one of the forecast, or one of the tools we use in our drought outlooks is the climatology. You know, how much precipitation falls during the next 3 months. So this is the median percent of annual precipitation. The July, August, September is a very wet time of year for Arizona. You can see more than a third of their annual precipitation falls during this 3-month time period. And in that southeast part of the state, more than half of their annual precipitation falls during this 3-month time period. So, you know, with an enhanced monsoon, this wet climatology, we are expecting some drought improvement during the next 3 months. Go ahead to the next slide, please. So, yeah, we're showing drought improvement over the southwestern U.S. I mean, it's important to note that this, improving drought conditions, but not an elimination of drought, as we could still have long-term drought impacts continue beyond the end of September. But yeah, fairly confident that with the enhanced monsoon, there should be some improvement, especially over Arizona. Also, with an active East Pacific tropical cyclone season, that should provide favorable moisture surges up through the Gulf of California later in August and September. So, yeah, there's the improvement in the Southwest. As you go farther north into the Intermountain West, broad-scale persistence is more likely. And there could be some development over Northern California if we have any prolonged hot spells coming up. And I think that's my final slide.
Great, thanks, Brad. Next, we'll hear from Mike Crimmins regarding ENSO and monsoon outlooks. Mike is a faculty member of the Department of Environmental Science at the University of Arizona and an extension specialist in climate science with Arizona's Cooperative Extension. His applied research and extension work focuses on southwestern U.S. climate variability and change, with expertise in climate services, drought, the North American monsoon, wildfire and climate interactions, and decision support for natural resource management. Go ahead, Mike.
Thanks, Amanda. So I'm going to talk today about the monsoon outlook. I'm down here in Tucson, and we're now kind of into the first week of July. The official monsoon season that's been defined by the National Weather Service offices down here, it's June 15th through September 30th. So we're officially a couple weeks into it. We've seen a little bit of precipitation. Yesterday, I saw rain across my neighborhood. I smelled it, but I didn't actually feel it. So that's actually what we're going to be trying to look for as we get through the rest of July, and then hopefully in peaking in August. Next slide, please. So this is a total precipitation percent of normal image from NOAA. and it's for the last 30 days. So it's through yesterday morning, and it's actually grabbing some precipitation we saw earlier in June right up until the official start date. And all I want to do is illustrate with this is those red colors are below or a very small percentage of the expected precipitation. And as you get into those yellows and greens and blues, you're seeing those more isolated, heavier precipitation. We have to remember too that the June into the beginning of July is climatologically one of the driest periods for the Southwest, especially in Southern California, Southern Nevada. And we're just starting to see precipitation climatologically in Arizona and New Mexico in this period. So it really is showing a pretty slow start, very isolated storms. If we move to the next slide, please. This is a precip product we use with PRISM data down here, just focusing on Arizona and New Mexico, just to illustrate how light the precipitation has been, especially across Arizona and Western New Mexico. The Great Plains have seen quite a bit of precipitation through the spring and leading right up until now. And that lower right image is anything that's white to green is caught up with average over the June 15th through beginning of July. And then everything that's brown hasn't seen that precipitation yet. So we're off to a start, albeit slow, a little bit clunky. And I want to talk a little bit about why maybe we've had this slow start. And then as Brad illustrated, there's some pretty good signs on the horizon, and it may be a little bit clunky, but then we'll talk a little bit more about how the rest of the summer might turn out down here, Southwest and Intermountain West. Next slide, please. Okay, so Brad already went over these, and anytime we see green on the map here, especially in the Southwest, we're excited and we're kind of leaning into it. So these outlooks out through the middle to end of July and for the rest of the season certainly point towards a lean of above average precipitation. So let's talk a little bit about what else is going on in the background. Next slide, please. So I'm sure you've all heard El Nino has started to really pop up on social media and in the media. And it has been a remarkable thing to watch over the last couple of months of this El Nino event, which had some murmurings or some glimmers of hope way back into March, where we were starting to see some interesting things occur across the equatorial Pacific. But that real steady march from the middle of April up to present, putting us up into solid El Nino territory, especially as we start to look at the multi-month averages. And if we look at that map in the lower right, you can see that real strong signal of above average temperatures from the coast of South America out through the international dateline, and especially in that rectangle of that Nino 3.4 region where we're measuring those temperatures to see how unusually warm or cool they are. And they're unusually warm for this year. So one thing I want to say here too is that typically El Nino isn't much of a factor in the summertime, spring into summer. It's usually forming, it's usually not connected with the atmosphere, but strong events like we've seen in the past can come on fast, and they can actually connect with the atmosphere and start to influence the summer weather pattern. So that's part of the story here today is that El Nino is certainly here, and it may be impacting our weather already, and it may impact the rest of the monsoon season. Albeit weak, we're really going to be starting to look to the fall and the winter for those real strong impacts across the continental U.S. Next slide, please. All right, so this is a really remarkable graphic too, issued by the NOAA Climate Prediction Center. That y-axis is percent chance, and so it's very rare you see in anything weather and climate that's up to 100%. So you can see here those 3-month moving windows down at the bottom. We can put us into that July, August, September, and we're close to 100%. And as we move into August, September, October, we're right at 100%. And then those colors are indicating the potential strength of the event. So as we move further into the summer, the event strengthens, and the probability of it being a strong to very strong event continue to increase. Next slide, please. So I want to step back here and just, when we have strong events, how do they impact the weather across the continental U.S., especially the Southwest here during the summer season? So this is a correlation tool. These are not very strong correlations, if you notice here, from -5 to 0.5, but they can certainly point at maybe a potential signal. So if the colors are yellows to orange, that means when there's an El Nino event present, it leads to above average precipitation, and when it's blue, below average. So across June, we can look in the Intermountain West, a little bit of a lean towards above average precip across some of the Four Corners states, especially Colorado. Not much of a signal down here in the Southwest with Arizona and New Mexico. As we move into July, though, notice that whole southern tier from the southeast all the way over to Arizona, there's a weak correlation, but that correlation is certainly there in past strong events that we have below average precipitation for the month of July. In the Southeast, typically suppressed hurricane season. In July here in the Southwest, though, it usually is a indication that the monsoon ridge, as Brad noted, is going to have a little bit of trouble pushing north. I think that's what we saw in the later part of June, maybe even this past week, but the models are indicating that we might be able to push past that. As we move into August, notice that the colors then move up to those Four Corners states and even north there, kind of weaker down here. And then as in September, it shifts over to Western Arizona, Intermountain West, and Southern California. Those two signals are most likely given where the ridge is climatologically positioned, and we typically see enhanced East Pacific tropical storm activity during El Nino events, is that we might see more pulses of tropical moisture move up Gulf of California, even off the California coast, move up around that ridge, and then give us those wetter than average conditions. So next slide, please. This is a great old tool from Dan's shop at the Western Regional Climate Center, and I just wanted to real quickly point out that historically, when we're looking at precip extremes, if you totally all up analyzing them statistically, past events that are El Ninos in July, that red color on that left graphic means we have fewer wet extremes during July, and on the right indication that we have actually more dry extremes. So it's just indicating what we talked about earlier, it's just a shift towards potentially drier conditions. Again, statistical, we may end up, driving right into a great monsoon pattern in a couple of weeks, but historically, this is typically the pattern. Next slide, please. And why we see this is, especially going back to Brad's model output there, was historically we would see that monsoon ridge just having trouble progressing north and having a trough in its place. Saw that in June, starting to see it be replaced by this ridge moving north. That figure on the right is the model that was the beginning of June, so I don't have the update for July right now, but this was pointing at this potential right in July. It's not a strong indication that the monsoon ridge is going to be totally squashed to the south, but it looks like it would have a little bit of trouble. But again, I think we're starting to see that replaced. Next slide, please. This is just another model output. This is the CFS for that same period that Brad was showing. Really strong ridge pushing up way north into Canada. And there's just little hints that maybe even little easterly waves are kind of coming underneath that ridge, which would come across the southwest and really enhance that monsoon moisture into the southwest. Next slide, please. And so if we back out on the whole summer, that left graphic, you can see it's white. So it doesn't show any indication for July, August, September during an El Nino of having a shift towards wet or dry extremes. But if you shift it 1 month forward to August, September, October, you start to see more wet extremes pop up in that period with an El Nino event. And that really is that indication that historically the East Pacific tropical storm activity and the moisture associated with it tend to favor the back half of the season. So even if the overall correlation is weak, I do think as we shift later in the season, the East Pacific becomes more important. Next slide, please. And we certainly see that. A lot of maps here. I just want to focus you on the upper left. That's the National Multi-Model Ensemble. Just look at those greens and blues and where they're located out through the East Pacific, up off the coast of Mexico, and they reach right up into the Intermountain West. I think that that's really picking up on that indication that we expect to see that East Pacific season pick up, get busy, start slinging moisture up here. Next slide, please. Just going to wrap it up here. El Nino is here. Typically doesn't impact the weather of the continental U.S. very much, but a strong event certainly can, and I think it will be a player in the monsoon. It's overall weak, but we have seen that weeks start transition fairly quickly, mid to late July, especially in the beginning of August, and have those tropical storms. And just remarkable how warm the water is across the East Pacific. That's another factor we did not see in 2023 with the last strong event, not quite as strong as this one. It was cooler than average waters in that period. We have much warmer water here. So all those factors playing together, I think, could lead to an interesting season. So I'll stop there, and thanks very much.
Thanks, Mike. Finally, in this panel, we'll hear from Kathleen Clow from the Desert Research Institute to provide an overview of the significant wildland fire potential outlooks. Kathleen is a PhD candidate in atmospheric science at DRI, and for the third fire season in a row, she's providing operational meteorology support as a meteorologist to the Nevada Bureau of Land Management. Go ahead, Kathleen.
Hi, thanks for introducing me. I'll be giving this briefing on behalf of Jim Wallman up at NIC. Next slide. So today as a nation, we're at preparedness level 4, meaning that national resources are heavily committed. We currently have 10 complex incident management teams committed across the West. And as a nation, our highest fire activity continues to be across Utah and Colorado. And you can see in the blue triangles where we have those teams committed. Kind of echoing, next slide. Echoing previous panelists, December through May temperature anomaly, it's been some of our warmest temps on record from 1901 to 2000 when you compare to that period. So for 131 years, some of these are ranked, the hottest. And that's leading to some higher fire potential as we've seen. Next slide. We've also seen lower than normal amounts of precipitation across the West. So you can see 2 3-month periods here, January through March, and then April through June. So kind of a persisting lower than normal moisture for the Four Corners especially, but generally across the West as a whole, we've seen that below average precipitation. Next slide. So Dan talked about this winter snowpack and how it's record low for the West. And I'm going to kind of talk about how that impacts our fuels as well. So I won't dwell too much on this since we've seen it, but go ahead and go to the next slide. So I'll talk about the rapid snowmelt a little bit as well. These are 2 figures from 2 different basins. On the left, we have the Severe Lake Basin in Utah. And then on the right, we have the Upper Arkansas Basin in Colorado. And this is where we're seeing a lot of our high fire activity. And you can see that this rapid melting of snow in March due to those warm temperatures had little to no recovery after that. So once we lost our snow in March, we stayed dry. In most lower elevation areas were devoid of snow by late March. And so next I'll talk about how this impacted our fine and heavy fuels. Next slide. So the lack of snowpack led to a higher carryover in our fine fuels, meaning more fine fuels like grasses carried over from last season. So we've got that kind of higher fine fuel load. We also had above normal fine fuel growth in those blue areas on this map, due in part to that early melt off, but also above normal precipitation, especially across Northern California. You can see those darker blue areas. So they've got a higher amount of those fine flashy fuels. The lack of snowpack and lack of precipitation across the rest of the West also impacted our heavy fuels as well, leading them to be drier than normal overall. And any small amounts of precipitation that we've gotten so far this spring has not really led to any kind of fuel moisture recovery in those heavy fuels. So overall, we've got drier heavy fuels and also a higher load of fine fuels in some areas in the West. Next slide. So again, echoing everything that everybody's been saying, you can see in the last month, it was really the case that we had below normal precip across the West and above normal temperatures. So this warming and drying trend that we've seen this spring continues to persist, but we do have that hope for some monsoonal moisture creeping in the next couple weeks, as previously mentioned by other panelists. So next I'll go over our significant fire potential outlooks for the rest of the summer. Above normal significant fire potential is forecast for much of the greater Four Corners in July and into eastern Nevada and portions of south central Idaho. Above normal significant fire potential is also forecast for most of Northern California and northwestern Nevada. Next slide. In August, normal potential will return to portions of the greater Four Corners due to that forecasted monsoon we've been discussing, but above normal potential will persist in much of northwest Colorado through northern portions of Utah, Nevada, and California. Above normal potential will also expand across central Idaho and western Wyoming. Next slide. For September, above normal potential is forecast to persist for northern portions of California and Nevada, as well as central and southern Idaho, with the rest of the West back to normal significant fire potential. It is important to note that when we say normal potential and there's no red on the map, we don't mean no potential. There is still significant fire potential, it just isn't above normal. Next slide. For October, the entire West will fall back to normal potential, which again, for California especially, we can still see some fire potential in October. This does not mean no fire potential, just back to normal. Next slide. And that is the end of my brief.
Great, thanks, Kathleen. With that, I want to say thank you to all our speakers right now. We do have a few minutes for questions. As a reminder, we are going to be using Slido. So if you are joining from the WebEx desktop app or the web app, you participate by using either the apps or Slido button on the bottom right-hand corner of your WebEx window. And please include your name and affiliation with your questions if you can. Also a reminder that if we don't get to your questions here, we have about 10 minutes for questions. We will do our best to follow up with you offline. And at the end of today's briefing, we'll also provide some contact information for state level experts across the region who may also be able to answer your questions. With that, we'll give some time to come in with questions. So we do have a first one that came in. This was, I think, after Brad's presentation, before Mike's presentation, but perhaps they could both answer this one, I think. This comes from Carter Williams. It says, with Utah coming off a record low snowpack and now above normal fires, does any of that factor into having a higher probability of monsoon moisture for the latter half of summer? I believe it came in during Brad, but right before Mike's presentation. So I'm not sure who would like to try to answer.
Yeah, I can jump in here, Amanda. Yeah, so one of the things, with the lack of snow, we have low soil moisture that can increase, heat, temperatures, and that can help to enhance the monsoonal circulation. So, I think that answers Carter's question, but yeah.
Yeah, I'm not sure if that meant actually. I had the same question whether he meant the snowpack itself or or what your outlooks maybe perhaps meant for that part of Utah in that latter half of summer. So maybe answer both potentially.
Oh yeah, sure. So yeah, with the increased chance for above normal precipitation, favoring improving drought conditions, but not an end to the longer term drought.
Great. I don't see quite any other questions yet. Perhaps I'll ask one while people have the chance to type some in. I thought it might be useful to explain perhaps here, Brad, at one point in your presentation regarding the monsoon, and Mike got into this, you talked about some confidence or how much confidence that perhaps the monsoon is coming. Obviously, Mike talked a little bit about the ENSO and how that could be impacting, and maybe it'll be in August. Could you guys elaborate more about potentially how confident or caveat that about the monsoon and the next coming weeks or month?
Yeah, I'll jump in again. I would say there's the pretty high forecast confidence with enhanced monsoon during the latter half of July. Models have been very consistent the past few days, showing this more favorable setup with the mid-level ridge axis over the Four Corners region. As Mike noted, late June into the beginning of July, that ridge axis is well to the south over northern Mexico. We had a deep trough westerly flow. So that was like anti-monsoon. That's not what you want to see. And with this changing pattern over the next couple of weeks, and once again, the models have been very, very consistent showing this. So yeah, confident that the latter half of July should be quite wet there in the Southwest.
Yeah, I'll jump in too, just to build on what Brad's saying too. Totally agree. I watched the forecast models a lot now too, and we have been looking for that ridge to push north, and it finally does look like it's gonna kind of break hold of that trough, shove it off to the west. Just to note too, climatologically, we're already a little bit late, and so even another week later, especially kind of southern Arizona. So it would be really, really unusual for us to not be in deeper moisture by the end of July, just climatologically. So that there's a little bit of added confidence, I think, just in that as well.
Great. We did get a follow-up question to the first question, to the question before mine. And it says, this is from Anthony Edwards. It says, Mike has talked about how a drier winter/spring is correlated with higher summer/monsoon precipitation, if I remember correctly. I think this has to do with sensible heating. I guess it's a little bit more of a comment than a question, but I'll throw it out there in case there's anything after that.
Was that for me, Amanda?
Well, I guess it was a little bit more of a comment than a question. I guess this person had. They were just confirming that's what you were saying was how a drier winter and spring is correlated with higher summer/monsoon precipitation.
Well, I don't know if I said that, but that's pretty.
Well, then
It's pretty contentious in the literature. There've been quite a few studies that have shown that drier winters can lead to enhanced monsoon circulation, but we do see plenty of instances where that's not the case as well. It seems to be, bracketed in certain historical periods. And I did work on a paper with a colleague recently where we found that in a period of decades and did not find that in others. So I think the mechanism kind of makes sense with sensible heating, low snowpack, but we certainly do find instances where other bigger factors, like El Nino, may muscle around some of those. So again, I'm kind of with Brad on looking at the very short-term forecasts certainly suggest that the circulation looks good. And then the hope is that East Pacific season really makes up the rest of the season.
Great. Thanks, Mike. Yeah, and that person's commenting back. Sorry for the confusion. So I think we've got some answers here. With that, I'll pass our last question, I think, or depending how long this one takes, over to Kathleen. Obviously, you showed a lot of the outlook maps, and the question is, what do you think will be the worst fire risk for the season or at this time? If we look into winter, are we still worried about fires in October, November, December outside of normal fire season? I guess just maybe give a little bit more about some of the areas you're worrying about in the short term and as we go into fall.
Yeah, I would say short term, the Four Corners region, of course, which we've seen our highest activity. I think in the longer term, looking, October, November, thinking about California and Santa Ana wind events, it's not out of the norm to get some fires in the kind of late fall area in California. So there's still the potential there. And those maps that we show where it's white doesn't mean there's no fire potential. Their normal fire potential will still see fires in September and October. But I think it's a little far out to judge kind of those later months. We'll have to see how the monsoon plays out. We'll have to see how precipitation plays out across California as well and how things kind of dry out. California has seen some record heat as well, some triple-digit temperatures in the central valleys. So we'll kind of have to see how the summer plays out. So I'd say it's a little early to tell, but those fire outlooks will continue to update as we get new information.
Great, thanks. I guess to add on that, there was a clarifying question or someone just wanted to learn more about the difference between fine fuels and heavy fuels and how do they impact fire behavior. I think you had a slide on fuels. They want to learn a little bit more.
Yeah, I can explain that a little bit better. So fine fuels, we're thinking about the diameter of fuels. And so our fine fuels are like your grasses, your small little twigs, and we'll typically call those 1 hour fuels. So as far as adjusting to the atmosphere, it takes that fuel about an hour. So if you get rain, about an hour later, the grass is adjusted to that moisture and it's increased its fuel moisture. When we talk about our heavy fuels, we're talking about our 1,000-hour fuels, thinking of those larger kind of timber fuels, and those take 1,000 hours to adjust to any kind of precipitation. So when you get this like short shot of rain, maybe it's like 1/10 of an inch, not very much, and then you're immediately hot and dry after, those 1,000-hour fuels are not recovering moisture-wise at all. They're continuing to dry. So it's kind of what we mean. And those 1,000-hour fuels are the ones that are carrying these large fires. So those large timber snags that are burning for days and days and days, that's kind of what we're thinking about when we're talking about those heavy fuels versus those fine fuels. I don't know if that helps.
Great. And with that, we've hit about 10 minutes of questions. So I'm going to go ahead and say thank you so much to Dan, Brad, Mike, and Kathleen for your presentations. And then so for the next panel and the next presentations, we're going to hear about drought impacts from Western perspectives. Drought impacts us all differently, and so we will hear about diverse drought impacts from multiple sectors across the region and about the experiences of those who are working to respond to evolving conditions. I'd like to introduce Seth Shanahan from the Southern Nevada Water Authority, who's going to be moderating the next panel. So go ahead, Seth, introduce yourself and take it away.
All right, thanks, Amanda. Again, my name is Seth Shanahan. I currently serve as the Colorado River Program Manager for the Southern Nevada Water Authority. We're a not-for-profit water agency based in Las Vegas, Nevada, who rely heavily on the Colorado River and interested in drought issues. We've got 3 great speakers to get to today: Brad Rippey, Steve Pope, and Dave Costlow. And first, we're going to start off with Brad. He is going to share with us some information about agricultural impacts across the Intermountain West, California, and Nevada. He's an agricultural meteorologist in the U.S. Department of Ag's Office of the Chief Economist and the managing editor of the weekly Weather and Crop Bulletin. He is an author of the weekly U.S. Drought Monitor and the monthly North American Drought Monitor. So with that intro, Brad, it's all yours.
Thank you, Seth. And I will jump right in. My contact information is there on the page, so I'll jump to the first slide. And I do want to take a broader look. I know we're focused on one quadrant of the United States, but the broad look here, I was the author of the U.S. Drought Monitor last week, so my imprints on this map. And I just wanted to point out how heavily stacked the U.S. drought right now is across the western half of the country, including the southwest region. 48% of the United States, of the lower 48, currently in drought, and about 2/3 of the country either abnormally dry or in drought. We have seen improvement in other areas, but not so much across this region that we're talking about today. And even though 48% sounds like a lot, we have actually seen higher drought coverage in previous weeks. 10 weeks ago, we had 63% U.S. drought coverage. And there's only a dozen weeks in the 27-year history of the Drought Monitor where we have seen higher drought coverage than we did back in April at that peak. Next slide. In the last 10 weeks, we have seen, as I mentioned, improvement, particularly in the southern United States. And even in the northern fringe of this region, we have seen some patchy improvement in places like northern Colorado. But for the most part, it's either been status quo or slow worsening conditions in a lot of the Southwest, unfortunately, as other speakers have alluded to. Next slide. I did want to take a step back because in terms of agriculture, and particularly rangeland and pastures industry, long-term drought matters, and it's very interesting how the drought has played out across the continental United States over the last 2 decades or so. You notice the ends of the decades, the end of the 2000s and the end of the 2010s, actually had very low drought coverage in the United States. And this is the continental U.S. as a whole, so not particular to this region. But again, just kind of a big picture look here. But we have had significant droughts in the early to middle part of each of the last 2 decades, roughly from late 2010 to the mid-2010s. And then starting again in 2020 to present, we have had mostly elevated drought coverage. And unfortunately, the western half of the country has borne the brunt of that from the high plains westward. That is important. We started this year, 2026, with the lowest beef cow or cattle inventory in 75 years, going all the way back to the early 1950s. You cannot replace a cattle herd immediately. It takes time, and it takes obviously years to rebuild inventory. We saw a big drawdown during the early 2010s. We started to recover, peaked again in 2019, but since then we've seen another drawdown in beef cow inventory. You notice that when you go to the restaurant, when you buy your beef in the store, it is expensive, and that's part of the factor is this drought, this long-term drought going back to late 2020. Next slide, please. So out of this office, we created a product called Ag in Drought, and it is posted on our USDA Office of the Chief Economist website. We have archives that are posted on the National Drought Mitigation Center webpage, available through the Drought Monitor webpage. I just wanted to highlight that if you, the circled yellow area there, that column, that's current ag in drought for those particular commodities or those crops. And I starred a few that, at least within this region that we're discussing today, have had some impact of the drought. So for current summer crops, go back to that. For current summer crops, sorghum, particularly in Colorado, is being affected. Winter wheat being harvested now, severely affected by this drought. As you move into the forage crops, so important in much of the Southwest and elsewhere in the western half of the country, hay stocks have been affected, alfalfa and regular hay. Of course, cattle inventory and cattle have been affected, and sheep as well, hit by this drought significantly. And you can see some of those numbers are quite high. So if you look at, for example, hay and drought, 40% of the U.S. hay production area is currently in drought. That's actually down a bit from a few weeks ago. Cattle inventory in drought, 45%. So really a significant percentage of agriculture in this region and elsewhere in the U.S. in drought. Next slide. Again, these maps are available. I've got the websites there that can be passed along. Contact me or contact the organizers here. I'll get you those websites. This is just to look at hay production areas in drought. And these maps, the dark green, 75% of the production area. The light green is 24%. So you add together all the greens, that's 99% of U.S. production for hay. And you can see where that overlaps the major and minor areas when we put the drought layers on there. So that's in the red shading. And so, as I mentioned, 40% of the current hay production area in drought. Rangeland and pastures are another thing that don't recover immediately if it starts to rain again. If you have drought damage over a period of years, it can take years to recover fully from a drought of this magnitude. So as you'll see in a bit, even though we've had some relief in some of these areas, rangeland and pastures have been slow to respond. Next slide, please. This is an in-house graphic. It's not publicly available, but anybody can duplicate this formula if you wish. I just created a simple formula with the USDA NAS condition numbers, mapped it over time, and you can see another way that this is impacting our rangeland and pasture conditions. This again is US, but a lot of this impact has been across the western half of the country. For each of the last 6 years, going all the way back to 2020, we have seen reduced rangeland and pasture conditions due to drought. 2026, no different, very low conditions. In fact, only a couple of years, 2021 and 2022, have had lower national rangeland and pasture conditions at this time of year, looking back over the last 10 years. So we continue in this drought that has hit mostly the western half of the country. Next slide. Here's the actual current rangeland and pasture conditions. We map these each week. And you can see Arizona, most of the Four Corners region, as a matter of fact. Utah is a little better in terms of the rangeland and pastures, but it extends up into Wyoming. A little better as you head west. In California, as other speakers have mentioned, actually in pretty good shape, but really rough rangeland and pasture conditions in many of these states that we're talking about today. Comparison to last year is in brackets, so you can compare to how it looked this time a year ago. And in many cases, we are worse, if not much worse. Next slide, please. This is the same type of graphic here, looking at condition, mapping it over time, year after year, going back 10 years. 2026, this is the winter wheat crop that was planted last fall. It overwinters, begins to grow again in the spring. It was basically a train wreck for the central and southern Great Plains. This, of course, includes states from Colorado southward for this talk, for the purpose of this webinar. And so you can see that it's been a rough run for 2022, 2023, and the 2026 harvested crop, all very low on the totem pole in terms of just how the condition has shaken out. And the next slide will show you how the abandonment of this crop was. Now, we actually had a slightly higher abandonment of the 2023 harvested crop, 33%. This year's abandonment of the U.S. winter wheat crop is pegged at 32%, meaning that for every 3 acres that were planted, only two of the acres are going to be harvested. One will be abandoned or never harvested. And if you go back in time, besides 2023, you have to go all the way back to the Dust Bowl era, 1933, to find a year with higher U.S. winter wheat abandonment. Next slide. Showing the winter wheat condition. This is the last report of the 2026 season. Colorado, obviously, kind of ground zero, along with Nebraska to the northeast on this drought. So certainly an impact on the eastern edge of this region with very poor wheat conditions as you move into eastern sections of Colorado and New Mexico. Next slide. And this is affecting summer crops in areas that remain dry. Colorado is a producer of sorghum, and it has really been hurt. It's a young crop still, but it has been hurt by this drought. More than half of the sorghum crop in Colorado currently in very poor to poor condition, based on the latest USDA NAS ratings. I believe that's my last slide, and I will, oh, no, I have two more. I'm sorry. I added in the topsoil moisture. This is a parameter captured by USDA NAS each week during the growing season, looking at topsoil moisture in agricultural regions. So some of these states don't have a lot of agricultural footprint, but nevertheless, a statewide value. Look at the Four Corner states, Wyoming and Nevada, all extremely low topsoil moisture, rated mostly very short to short. California doing better. And then the other product, subsoil moisture, and this is below 6 inches. So this is looking at deeper, and it also shows extremely dry conditions all the way at depth from topsoil down deep through the subsoil. And again, it shows the impact of this drought across this region, except California. And that is it.
All right. Yeah, thank you, Brad, for sharing all those details. Quite interesting information. So let's get to our next presenter in this session, and that is Steve Pope. Steve is the general manager for the Uncompahgre Valley Water Users Association, and he assumed that GM position of the Users Association in December of 2021. And among his responsibilities are the oversight and operation of the Gunnison Tunnel project and the irrigation deliveries to 84,000 acres of farmland in Montrose and Delta counties. Steve, it's all yours.
Thank you very much. If we can go to the first slide, please. Just a general overview as we lie on the western slope of Colorado, kind of central to the state. The Uncompahgre project was one of the first projects authorized under the Bureau of Reclamation in 1904. And, as mentioned, we irrigate about 84,000 acres. We have a tremendous amount of infrastructure, roughly 700 miles. And our primary crops in our region are field corn, onions, beans, alfalfa, grass hays, and a lot of specialty crops, one of them specifically being the Olathe sweet corn and a lot of seasonal vegetables. Next slide, please. Our main water sources we get to, and the primary source is the Gunnison Tunnel. The secondary sources are direct flows out of the Uncompahgre River. The Uncompahgre River, this year, our system is comprised of a couple of different smaller basins, and the Uncompahgre River, or the Uncompahgre Basin, is been most challenged with snowpack. I want to comment that each of these flows really impact us differently. I'm kind of show that we had about 106,000 acre feet in an irrigation pool that services the Gunnison Tunnel, and most of the water comes through the Gunnison Tunnel. Next slide, please. If you look at our snowpack, and it was mentioned before in the Uncompahgre, March being our greatest month for accumulation of snowpack, we ran about 9% in the Uncompahgre Basin. Again, as mentioned, the warmest March on record. Some of the SNOTEL sites up there showed that it was by far the worst snowpack on record, and that really impacted our system. Next slide, please. So the Uncompahgre Basin, which services our Ridgeway Reservoir, is directly south of us, and that basin contains the snowpack initially this year was supposed to be roughly, started out the season fairly strong, about 75,000 acre feet average. We ended up with roughly 24. Virtually received no direct flow water rights from the Uncompahgre this year, which forced our system to operate at 50%. Currently, our large producers are fallowing between 30 and 60% of their lands. And some of the issues that really trigger that is, yes, this year is going to be difficult. We've got a tremendous amount of fallowing, but next year, the issue is with weeds, and all of the fallow ground is maintaining that and dealing with the unintended consequences of leaving this ground fallow really will impact their production. Further out in the basin, if we could go back a couple of slides to a map of the valley, we represent, right there's perfect. Just as a side note, right below that blue arrow there in the lower right-hand corner of the picture is where the Gold Mountain fire is right now. There's 32,000 acres that I believe is to date being burned up. So it really, it's going to impact our watersheds. It's going to impact, some of our deliveries. We're going to deal with a tremendous amount of debris flows from future runoff if we ever get any monsoons. So these are some of the other issues from a water management standpoint that are challenging to us as far as delivering water to producers. I guess one of the issues, and it's just off to the east of that red arrow, is Blue Mesa Reservoir. It's one of the original CRISP units. It's one of the largest. It is the largest reservoir in the state of Colorado. We are projected to be at Deadpool by October. So that will really force some administrative challenges for our system when it comes to operating and going into the next year. We may be forced to place an administrative call on the Black Canyon around the Gunnison River through the Black Canyon, which would impact fish flows and flows for record of decision. So there's a lot of challenges with getting even a 50% allocation out of our system. So our producers, not only they're dealing with the water challenges, but with it is the unintended consequences of weeds, pests that are always a challenge here for us, and just the unreliable snowpack we have, since we are so dependent on hydrology to satisfy our needs. I think the future for us, we're continuing to live within our means, try to make operational improvements to our system without passing those costs on to the large scale producers. And then further to the north of us, a lot of our neighboring partner water districts, they grow more orchard-based crops, and they just don't have the ability to fallow. So they're in full survival mode right now. They've been nipping buds as soon as the fruits start to produce, just to keep the trees alive for this year, in hopes that next year will bring some better conditions for us. That's one of the challenges I think that every basin in the western slope of Colorado is facing. They're all unique challenges. We each have our own specific struggles when it comes to being able to deliver water for our producers, the producers' needs, and their ability to fallow, and how they're going to recover from this drought or these ongoing drought conditions. I believe that was, if we go down to my last slide. Yes, and the last one I wanted to talk about was, in addition to us, we talk about supplying water to agricultural users, we're also the raw water supplier for the domestic component of this system. So any changes to Blue Mesa Reservoir, specifically when the elevation of the reservoir decreases, we receive these large algal blooms, and that really puts challenges as far as water quality issues into our system that can somewhat impact farmers, but more the municipal side of the raw water delivery that we provide to the municipalities within our service area. I think that was the last slide I had.
All right. Yeah, thank you, Steve. Clearly a challenging year, and we'll have some time for questions in a little bit, but let's get on to our next speaker in this session. And our final speaker, it's David Costlow. David is the executive director of the Colorado River Outfitters Association, and we'll talk about some of the recreational impacts we're seeing from this and
very good
this drought. So David, it's all yours.
Yeah, thank you. Next slide. So we're an industry, I'm going to talk about rafting in Colorado, not other states, but in Colorado. But we're primarily an industry that interacts with small communities, because that's where the river locations are. We are not an urban industry, and the number of people that go rafting affects those small communities. Next slide, please. So here's a map that kind of indicates some of the small communities throughout the state that we interact with. Next slide. So a population breakdown, you can see just glancing through here that we're talking like Winter Park, less than 1,000 people living in Winter Park, 18,000 in Durango. The largest city on here with a river near it is Fort Collins. And next, here you can see, for those not familiar, here are the locations of many of the river and river segments that we run as an industry. And you can see the bulk of them are on the western slope, not the eastern slope. The Costlow is one of the exceptions. So is Clear Creek and the Arkansas rivers. Those all flow eastward. Next. So a lot of our business is driven by visitation to national parks. And we're the recipients sometimes of those visitations because people also want to go rafting and do other activities while they're in the location for vacation. Next. Every year we produce a commercial economic impact report, and we show the number of users that have gone per river for that season. And the next slide shows the years 99 through 2010. I chose this one because in 2002, as you see, I have it highlighted, the column there, was a severe drought here in Colorado. And you can see the number of users going rafting dropped significantly. And at the bottom, you'll see it was over 100,000 less people in the 10 or 11 weeks that we rafted. So the one exception to that, if you look down in the third segment there where it says Colorado Upper, you will see that the visitation there grew during the drought year. And the reason is because of water storage. Toward the end of the season, there's more water in the upper Colorado region, that segment of rafting, than in other locations. So as many outfitters as can try to relocate their operations there and have customers embark from town of Kremling and go down through that segment. Next. Another dry year we had was 2002, or I mean, it's 2012, 2002 being the first one I'm showing, 2012 being the next one. You can see that we dropped, if you look at the very bottom row, you'll see that we dropped in numbers for user visits, but it didn't drop as drastically. And part of that was we learned a lot as an industry from 2002 how to better prepare for drought and run trips for drought. We're better at moving trips around on different segments of the river, and we've done things like engaged in buying smaller boats that can navigate the rivers much better and allow those crafts to be able to go down the river more efficiently than if we were using the regular large boats that we might use during high water years. Next. Here's another pictorial just to give you a sense of the commercial user days. You can see both in 12 and in 2002 how drought really affected our industry. Next. And this is the economic impact report showing that in those communities, we think the economic impact was diminished during both those two drought years. Next. So part of our mission as an association and as outfitters in general is to communicate accurately to the media, to customers, what the river conditions are like, so that we don't want people going out on the river and not having a good time. So we have a large crowd of people, a lot of them local people, that wait till low water season to come out for the summer to engage in rafting. They're avoiding high water. We have another group, a smaller group, that really enjoys the very high water. This year we did not have high water. And so the low water season started early. It's going on, of course, right now. Next. And the thing that we've got to be careful of is the perceptions of drought sometimes can be worse for us than the actual drought, where people think that the conditions are such that they're not going to have fun. For most of June, we had what we would consider late July, early August water conditions. And every year we have those conditions. So we're used to running at those water levels. And we don't want people to think that there's conditions such that it isn't worth booking a trip and coming out. Next.
David, I'm so sorry to interrupt, but we are close to time.
Okay. Next. we have high water, we have low water. Both of those present challenges to us. Give me the next slide, please. And the message I want to leave you with is that low water does not mean no water. So we have water for rafting. We're rafting today. We're counting on reservoir releases, and we're totally optimistic that those monsoons will occur soon and augment the river flows for us. Thank you.
All right. Yeah. Thank you, David. Very much appreciate that and all our speakers. I think we do have a few minutes for questions. And just to remind folks, we're doing that through the Slido app. And so if you're joining from the desktop app or the web app, you can participate in that by clicking on that little icon in the lower right corner called apps, or sometimes it says Slido. If you want to go ahead and add your questions there, we'll go ahead and take them. And if you could include your name and your affiliation, that would help as well. And I do see that there is at least one question listed. So I'm going to go ahead and start this one. And I think a good answer, it would go to Steve Pope here. Steve, here's the question coming from Charming P. Evelyn. Is recycled water used at all to offset any of the snow drought that you're seeing or expected to see in your service area?
We recoup, our system is set up to where we use and reuse water 6 to 7 times as it runs through our system. Our system, the rivers themselves are not sufficient to provide water to the field and just have it flow through, even under a normal year. We're heavily focused on recapturing our water, reusing it for agriculture as it works through the system. I think most agricultural districts are just doing that out of a standard practice. They long have, just as a matter of efficiency for deliveries.
And maybe just a follow on, Steve, would that be the same case for your M&I water that you all deliver to?
Absolutely. I mean, once that water is returned from the treatment plant, it's into the river, and we have 7 canals, and so we physically pick up everything as it comes down. So that water's reapplied to for agricultural purposes as well.
Yeah, great. Okay. All right, as we're waiting on some other questions to come in through Slido, I'll ask a couple. Maybe for Brad, with the news about the monsoon, what would you say about the monsoon, and perhaps does it offer any relief for producers, and any other thoughts you have on that topic?
Yeah, certainly it's good news coming from Brad Pugh and CPC that it looks like we've got a monsoon surge coming here soon. So that is as he mentioned, a critical source of water, and up to half of the annual rainfall in a few spots comes from that. People don't realize how important the summer rains are in the Southwest. That's certainly one big thing. It will cut irrigation demands, so it can conserve water and kind of string along the amount of available water a little bit longer. And then certainly for rain-fed crops, it's a big boon because they depend on the rainfall this time of year anyway. So good news to hear that hopefully we've got a robust, albeit slightly late monsoon.
Yeah, that's good. Maybe a little bit of good news. That sounds great. Okay. Go ahead.
Beth, I would like to throw one, regarding the monsoons too. And I mean, it's, from our perspective, from water management and the agriculture, we love the monsoons, but if you ask any farmer, the easiest way to make it rain is for them to cut their hay, or so at times those monsoons, when we're seeing the intensity of them, they actually can cause some challenges from the production side. I love the monsoons in the mountains because it provides us with 2 or 3 days of water supply, but you hate to see those super intense storms on that ag land.
Yeah, that's an excellent point. I've heard that often too. So thanks for adding that. How about maybe one other question for David here? David, do you have a sense of the recreationists, what they do in a year like this? I mean, you see clearly, or you showed that there's impacts in bad years like this potentially, but there's still water, as you mentioned. So what are folks doing? Are they staying home? Are they going elsewhere? What's your sense of
Well, I think we'll have diminished number of rafters this year compared to like last year. And part of that's due to the drought, and we missed that high water crowd for sure. So we're just optimistic we can have a full season on many streams. But to do that, we're going to need moisture, and we're going to need reservoir releases so that we can ride that water. So I think locally some people sit it out this year, which we encourage them not to, because they'll come next year in July at the same water levels, late July. So again, that's part of the perception we want to overcome with people, that it may be a drought year, but some of the water levels are equivalent to what we've seen every year at late in the season. We're just having them earlier than we usually do.
Yeah, that's a really interesting point you made there, that you do see some of this water, but just at other parts of the year. Okay. Mm-hmm. Timing, it appears to be an important thing. And given that as the theme of timing, I think we'll go ahead and close this session and say thank you to all of our speakers, Brad, Steve, and David, for giving us a sense of some of the impacts across the Western U.S. as it is associated with this conditions that we've had. And so I think with that, we'll go ahead and back to Amanda to finish us off. So Amanda, it's all yours.
Great, thanks, Seth. I want to add my thank you as well to everyone on that panel, on the first panel, who shared their time and expertise with us today, and everyone who worked behind the scenes to make this briefing happen. As a reminder, the recording will be available on the NIDIS YouTube channel and linked from the briefings event page on drought.gov. And also just a reminder, as you can see on the slide here, drought.gov is a great resource for timely and relevant information, and where we will continue to post stories, drought status updates, and regional webinars throughout the remainder of the summer. Next slide. And then here is also a list of additional state contacts for your reference in case you have some specific questions that our speakers couldn't answer today, or just a specific question, some of the folks there. I'll go ahead and leave that slide up for a minute or two in case you'd like to catch some names and information. Okay, well, we can go to our final slide. Again, just a big thank you for attending, and from all of us at NIDIS, I just want to say thank you all for joining us today. And with that, we'll go ahead and conclude the briefing. Please reach out if you need more.